So what I'd like to talk about the 6000 series right now is that this is really the first color inkjet printer designed to be a thermal transfer replacement. Partly that means this printer is ready to accept popular computer languages like ZPL directly, meaning I can unplug this printer from my existing ZPL data stream that might be talking to a thermal transfer printer, plug this printer in its place, and it's ready to print. It has the advantage of color over monochrome, and it's a lot easier to use. So let's just start talking about loading the media. Okay, something that you're going to have to do every day as you access the printer. On the Epson printer, you can see I can open the cover actually from this way. Means I can access the labels from the top, front I should say, from the side. I actually could even access it from the back. And I think people understand that a lot of workspaces are really constrained, and that flexibility is big. Okay? In contrast, when we look at a typical thermal transfer printer, I have to have some place, which basically means I've got to work off this side. So obviously I cannot put anything over here, and really there's not much I could do from the rear of the printer. So I have to leave the side open. So I have that one disadvantage right there. So now when we look to get the media out of here, I have to open up the head station, pull my media out. Okay, I'll take my media off. And now assume this is a new roll I'm going to have to load in here. When I go to put the new media in, I'm kind of at a little bit of a disadvantage trying to figure out how to thread this into the machine under this bar, behind this guide. Okay, out through the front. Okay, got it almost. Okay, lock it down, and there I am. Okay, not too bad, but that threading, especially if I don't have light and things like that, maybe not optimal. Compare and contrast. I'll take my media out of my 6000 series here. It's on a carrier. I could either put another roll on this carrier, or let's assume I have another carrier standing by. I drop my media in. I push it into the print station. Shut it, and I'm good to go. So now I will unroll my ribbon here, and you'll notice the ribbon comes with a special sticky leader on it. I'll take that. I will now slip this onto the starter spool here, and now I have to get this media loaded. Again, I have to thread it through the mechanism. Okay, come around through here. Okay, and then I've got to carefully stick it on the take-up spool. Okay, now I have to wind some through. Because when you see here it's wrinkly, I have to make sure that I get at least enough mechanism through that it looks nice and clean. I think I'm about good there. And there, I've changed a ribbon on my thermal transfer printer. Now let's compare and contrast doing it on the 6000 series. Okay, I open up the lid, take out the ink. Maybe I have 2 inks that need to be replaced. Put them back in. Okay, and you can see that operation is just a lot simpler. Okay, so you got somebody out there that's not familiar, the lighting isn't good, whatever the work situation, I can just change the supplies a lot easier on my C6000 series printer. So of course, one of the main reasons we're going to use any of these printers is to print barcodes. So now let's look at what's involved to set up and get a proper barcode out of each printer. Okay, what I'm showing here is basically what's involved in a thermal transfer printer, which has the variables of pressure, heat, speed, ribbon, and media. And these all interplay with one another. Okay, so that if I have a different one type of ribbon, I might need more heat or less speed or more pressure. Okay, and what is the impact of this? Okay, so let me talk about what actually makes a barcode. A barcode becomes readable when the ratios are accurate. Okay, so for example, in a typical 4-element barcode, we have sizes of 1, 2, 3, and 4 being wider or narrower. And I'll point out that the white space in between a black bar is also an element and has the same size and proportion requirements. Now, the challenge you have with the thermal transfer printer is using all these variables, it is very easy to overburn or underburn the barcode. What does that mean? When I overburn the barcode, suddenly everything is too big. So here's the ideal barcode, but when I have too much heat or maybe too slow or maybe the wrong ribbon for that particular heat setting, suddenly everything gets wide. And you could maybe see that all the white elements are suddenly shrunk and the big elements are big. And now the question becomes, for any reader down the road, is this element supposed to be a wide, a narrow, a medium? What is this one supposed to be? The net is the barcode isn't readable. And on the other side, if I overdo these settings, I actually underburn the barcode. Means maybe the ribbon needs more heat, or I went too fast, or my media was not appropriate, and suddenly all the little bar elements become skinny, or maybe suddenly develop some small voids within them. So the net of it is fairly involved tuning mechanism, changing all these different variables. And as you can imagine, with 1, 2, 3, 4, 5 different variables all having the same interplay, to get the right barcode is not so easy. And so typically with the thermal transfer printer, you're going to need a barcode verifier that will allow you to try a label, scan it, check quality, and reiterate until you get this right. Is that an operation that is easily done by an unskilled operator? Probably not. Now let's compare to the 60,000 series. Okay, what do you actually have to do to print? The precision core head is very dimensionally accurate, 1200 DPI. It really doesn't have anything analogous to this tuning procedure. So you can see the difference in getting reliable barcodes is a huge difference in setting up the two printers. One of the other adjustments of a thermal transfer printer is the head pressure. Okay, the head is directly in contact with the media, so we have to adjust this. And it has these adjusters. In this printer, I can adjust the tension in these two spots. In other printers, especially an 8-inch printer, the location even is a variable. It has to be done correctly because you can see if I don't have enough pressure on the left side is blank. If I don't have enough pressure on the right side is blank. If I get it almost right, well, I can still see I have artifacts here. So it really has to be accurate, putting even pressure. Okay? And if I put too much pressure, I'm going to start putting wear and tear on the head. Maybe it's not so bad when I'm doing full width labels, but if all of a sudden I switch to maybe a small label like this, I'm in a whole nother issue of trying to get it dialed in to give me even pressure on this little label and make a quality printout. So we've discussed the difficulty in setting up the barcodes, but let's assume that we've done all those settings and we got the printers printing good barcodes. Let's talk about consistency of barcode quality. One of the challenges we're going to have on a typical thermal transfer printer is the media itself, the ribbon. Okay? As you can see, this is a large, thin slice of mylar. It's very easy over its operation to generate wrinkles. And those wrinkles are going to create voids through the barcodes that will not necessarily be detected. Meaning you could look at the first label, looks fine. The last label looks fine, but there's a bunch of barcodes that are not scannable in between. The second thing is the print head itself. The ribbon and the media are dragging against that print head, wearing it down, and it's going to eventually grind through the pixels on the print head. And the process itself, using so much heat and cooling, are going to cause these pixels to fail, which will cause stripes through the print and will cause it to ultimately fail barcodes also. And they may not be so easy to see. And finally, there's sometimes just voids in the material where there's just maybe a piece of the resin or wax on the ribbon or a flaw in the media that may also cause a problem like that. These errors are not detectable by the printer itself. It doesn't know that it wrinkled. It doesn't know that a pixel is burnt out. It doesn't know that there was a void in the print. So let's contrast with the 6000 series again. The 6000 series has a nozzle verification technology that actually verifies the integrity of every single pixel in that head. Okay? So before you print, it will check the print head, verify that it is 100% functioning, and therefore, when it prints, I know that it is not having anything to do to introduce errors. There is no ribbon to wrinkle. There is no contact with the media against the head to be a problem. And I think over the lifetime, you're going to find out a much more consistent production of high-quality barcodes with the 6000 series. The most important thing is, how is the actual print quality? What does it look like? How durable is it? So let's take a look at the printer's printing, and we'll compare and contrast. Okay, so let's talk a little bit about print quality. Now, one of the things we can see when we look at these here is that the ColorWorks sample, the text and the fonts are super sharp and readable. And it may be hard to see that on camera, but when we get down to these same size fonts on the thermal transfer, we're really losing all the detail. And you can see the crisp lines in this barcode, and we can see it's just having a little bit of trouble trying to render that code in the same thing here. Now, another aspect, though, of course, is even if it does print properly, is how durable is that image. So let's say I get something as simple as some suntan lotion. Maybe somebody has that on their hands. And you can see here, if I try to rub this on this sample here, it really doesn't have any effect. But on the other hand, when I hit this guy here, you can see there comes my image off. Of course, this is only a wax ribbon and is not meant to be the most durable. So let me demonstrate with what is really considered a premium durable solution. Okay, so we saw that the wax and really isn't intended to be that durable. So now I'm going to use actually a Kimdura material. In fact, this is Kimdura for the color inkjet, Kimdura for the thermal transfer, and I use a premium resin ribbon. This is really the hallmark of reliability of thermal transfer. And we can see that when I try to rub that oil on there, it really holds up great. And so does our color inkjet, okay? However, if I just reach around my garage and get a few other things, like maybe this adhesive remover, it looks good there. It just washes off. How about some nail polish remover? Let's hit our color inkjet with nail polish remover. How about our thermal transfer with nail polish? And there's our image gone again. How about some paint thinner? This type of thinner. Again, the inkjet is fine. And there goes our barcode. And so what we see is, even when we get into the resin ribbon on a premium material, we just don't have the durability of color inkjet. So that concludes this video. I hope you can see why I'm so excited about the C6000 printers, and I hope that you learned something today, and thank you for your time.